Okay, so in this video we want to start looking at logarithms. So the first question that naturally arises is, what are logarithms? And logarithms are the inverses of exponentials. So just as the square is the inverse of the square root, the cube is the inverse of the cube root, the logarithms are the inverses of exponentials. So just as exponentials have their own exponential laws, we'll see that logs have their own log laws. So what's the first log law that we have to worry about? Well, let's fix a base 10, and I have log 10x plus log 10y. Now remember, with exponentials we had that multiplication gets sent to addition. Well, since we have the inverse now, we'll see that addition gets sent to multiplication. So log 10x plus log 10y will be log 10x times y. Similarly, since division gets sent to subtraction with exponentials, we'll see that subtraction gets sent to division. So log 10x minus log 10y is log 10x over y. And the last log law that we'll look at before trying an example is that if we have any number k times log 10x, then we can raise it up. So we have log 10x to the k. And this follows from this log law, which you can easily see. So for example, if I have k times log 10x, then that's just log 10x plus itself k times. Let's write this a little neater. K times. But then by the first log law, if I add logs, that's the same as multiplying them. So I multiply x by itself k times, but that's the same as log 10x to the k. Now none of this mattered. It doesn't matter what the base is. I could have done log 2, log 5, but for simplicity I just chose log 10 for these examples. Okay, so let's look at our first example. Simplify 2 times log 10 of 5 plus log 10 of 2 minus log 10 of 20. Okay, so the last log law tells us that if we have a factor out the front, we can bring it up. So in fact, 2 log 10 5 is the same as log 10 5 squared, which is log 10 of 25. Now we have log 10 2, nothing happens there, minus log 10 20. Okay, so what we have now is log 10 25 plus log 10 2 minus log 10 20. Now if we add logs, we multiply the insides. So this gives us log 10 of 50 minus log 10 20. And if we subtract logs, we divide the insides. So I have log 10 50 over 20, which is log 10 5 over 2. Okay, so let's just state a few things that may have not been explicitly stated. So the first thing you have to do, if there's a factor out the front, you need to bring that up before you add the logs. So notice here that I did 2 log 10 5 is log 10 25. I did that before multiplying the insides. you can't do it. You can't simply go 2 times log 10 of maybe 20, 10. You need to bring it up. And you also need to worry about the bases. The bases need to be the same, right? If I do 2 to the x times 3 to the x, I can't simplify that really. But if I have 2 to the x times 2 to the y, then I can use my exponential laws and say that it's 2 to the x plus y. Okay, let's look at another example. So here we have simplify 3 log 2 1 plus log 2 5 plus 1/2 log 10 9. Okay, so we'll bring this up. So 3 log 2 1 is log 2 1 cubed, which is just log 2 of 1. Similarly, we'll bring the 1/2 up. So I have 1/2 log 10 9, which is log 10 9 to the 1/2. Now remember, by index laws, or what we did in our study of index equations, was that 9 to the 1/2 is the same as square root of 9, and the square root of 9 is 3. So I have log 10 3. And now these two I can add, because, well, I can multiply the insides because they have the same base, but this log 10 3 stays on its own. So the final answer, which maybe I'll write in red to make it clear, is log 2 of 1 times log 2 of 5 plus log 10 of 3. So what I'm left with is log 10 5 plus log 10 3. Okay, for the final example, let's see if we can do a show question or a proof problem. So we want to actually prove a new log law. So show that log AB is equal to 1 over log BA. So I can switch these numbers, but what happens is that I have to divide by, I have to pretty much reciprocate the logarithm. Okay, so let's see how we would prove this. And this is actually going to be a general strategy to prove any log law. So this is, log AB is a number. If I set A to be 10 and B to be 5, then I get a number. So what I'm going to do is I'm just going to write log AB equals K. It's got to be some number, so we might as well just call it K for the moment. Now if I want to get B on its own, then there's a general rule for this, and the mantra is base to the answer equals the middle. Okay, so what does that mean? The base is A, the answer is K, and the middle is B. So base to the power of the answer equals the middle. So that's how I get B on its own. Okay, now what I'll do is I'll take log B of both sides. So I get log B of A to the K is log B of B. And I can bring this K down by the third index law. So I get K times log B of A equals log B of B. And now I need to figure out what B is. So this is also, so it's a proof within a proof. So let's set log B of B equal to, let's call it P. It's same reasoning as what we did here. Then base to the answer equals the middle. And so what does P have to be? Well, by basic index equations, P has to equal 1 because the base is the same. So if we apply that to here, what we find is that K log B of A is equal to 1. But now I can just divide by log B of A, and I get 1 over log BA. But what was K? K is log AB. And that proves the log law that I wanted. Okay, so let's review what we've done in this video. So we have 3 log laws that are parallel to the exponential laws that we saw. So we see that addition gets sent to multiplication, subtraction gets sent to division. If I have a multiple out the front, I can bring it up, so multiples go to powers. You have to bring the multiple up, so you have to raise the middle to a power if you're going to simplify the expression. You can only simplify expressions with the same base. This is the same as what happens in exponential laws and exponential equations. And we also have this additional log law. And if we ever are worried about what the value of a logarithm is, the general procedure is the following. So you set that quantity equal to k, or p, or some letter, call it whatever you want. And then you use the idea base to the answer equals the middle. We're gonna see, this is gonna be one of the really important parts. So this we will see over and over again when we solve logarithmic equations. And so if we do that, we get a to the k equals b. And then using the third log law, we bring the k down. And we needed to figure out what log b of b was. So we did the same procedure, base to the answer equals the middle. And I get b to the p equals b to the 1. So therefore p has to be 1. And then if we included that in our computation, then we just divided by log BA, and that proved the log law. Again, it's always important to practice this material, so check the video description for the Tute notes, and if you want fully worked solutions to these problems, check the cheat notes as well. Okay, thanks guys.